When the universe was still a baby, less than 1 billion years old, some of its stars turned into monster black holes. Black holes are among the strangest things in the universe. Well, in this video, let's learn basic things about a black hole. Firstly, what is a black hole? Many would say it's something in space which pulls everything. That is the standard answer you get from someone who got introduced to black hole in the movie Interstellar. But what is a black hole in scientific terms? How does it form? What does it do? And why are they important that from Albert Einstein to Hawking, everyone is crazy about it? In scientific terms, a black hole is a place in space where gravity pulls so much that even light cannot get out. Gravity is so strong because matter has been squeezed into a tiny space. This can happen when a star is dying. According to theory, there might be three types of black holes: stellar, supermassive, and miniature black holes. Stellar black holes form when a massive star collapses. Its mass can be up to 20 times more than the mass of the Sun. There may be many stellar mass black holes in Earth's galaxy called the Milky Way. The largest black holes are called supermassive. These black holes have masses that are more than 1 million suns together. Scientists have found proof that every large galaxy contains a supermassive black hole at its center of the Milky Way galaxy, and that is called Sagittarius A. It has a mass equal to about 4 million suns and would fit inside a very large ball that could hold a few million Earths. No one has ever discovered a miniature black hole, which would have a mass much smaller than that of our Sun. Black holes can be big or small. Scientists think the smallest black holes are as small as just one atom. These black holes are very tiny but have the mass of a large mountain. Another division separates black holes that spin from those that don't spin. Now let us discuss about the formation of a black hole. But here's a recipe to make a black hole. Start with a sizable amount of hydrogen, enough to make a star about 25 times the mass of the Sun. That hydrogen will begin burning into helium. Let the star cook for a few million years and it will start to run out of hydrogen to burn. Then it will begin burning helium into carbon or oxygen. These elements will fuse to make others in a chain of different fusion reactions, and eventually it will start producing iron. Iron can't produce energy via fusion, so the star will run out of the fuel that made it a star. Its mass will collapse inward and bounce off the iron core, producing a supernova. If you started with a big enough star, then much of its mass will be concentrated in a space so dense that light cannot escape, resulting in a perfectly cooked black hole. As far as we know, most black holes are made from a tremendous amount of matter being concentrated in a very tightly packed space. In theory, though this doesn't have to be the case, Einstein's formula E is equal to mc square tells us that energy is equivalent to matter times the speed of light squared. Here's where the Kugelblitz comes in. German for ball lightning. It is a black hole made from light rather than matter. By light we mean any kind of radiation, really. Although light has no mass, it does have energy. Since gravity treats mass and energy the same, in theory, we can focus enough radiation into a tiny space and produce an event horizon, an area in space so densely packed that nothing can escape. If we developed a laser that shot gamma rays, the most energetic form of electromagnetic radiation, that was magnitudes more powerful than any laser ever built, and focused it on a very precise point in space, we could make ourselves a Google Blitz. Now I'll talk about the favorable conditions to form a black hole. A black hole of a kind supposed to result from the complete gravitational collapse of an electrically neutral and non-rotating body having a physical singularity at the center to which infalling matter inevitably proceeds and at which the curvature of space-time is infinite. A Schwarzschild radius is the radius of the boundary of a hole of this type. It is a physical parameter that shows up in the Schwarzschild solution to Einstein's field equations, corresponding to the radius defining the event horizon of a Schwarzschild black hole. It's like a characteristic radius associated with every quantity of mass. The next one we have is the Chandrasekhar limit of 1.4 solar masses. It is the theoretical maximum mass of a white dwarf star that can have and still remain a white dwarf. Let us now discuss about the parts of a black hole. Event horizon. In general relativity, an event horizon is a region in space-time beyond which light cannot totally escape, because the gravitational pull of a massive object becomes so great as to make escape impossible. Relativistic jets are very powerful jets of plasma with speeds close to the speed of light. They are emitted by the central black holes of some active galaxies and by the black holes of massive stars and neutron stars. Ergosphere touches the event horizon at the poles of a rotating black hole and extends to a greater radius at the equator. With a low spin of the central mass, the shape of the ergosphere can be approximated by an oblate spheroid, while with higher spins it resembles a pumpkin shape. Accretion disk is a material like gas, dust, and other stellar debris that has come close to a black hole but not quite fallen into it, forms a flattened band of spinning matter around the event horizon called the accretion disk. Photon sphere is a location where gravity is so strong that light can travel in circles. Photons orbit the black hole at the distance of the photon sphere. A photon could leave the back of your head, go once around the black hole, and be seen by your eye. The innermost stable circular orbit, often called the ISCO, is the smallest circular orbit in which a test particle can stably orbit a massive object in general relativity. The location depends on the angular momentum or the spin of the central object. In the center of a black hole is a gravitational singularity, a one-dimensional point which contains a huge mass in an infinitely small space, where density and gravity become infinite, space-time curves infinitely, and where the laws of physics as we know them cease to operate. Please like, comment and share, and do subscribe to our channel.